Wait, what are you doing here? You dropped from BC? Well, nice to see you. Notes are on the back table. And then just pick an open seat, but not this one. Because he didn't drop. You know, Barrett? All right, so we are going to. Okay, we're going to cover our last new thing before your test. Okay, girls, are we ready? Yes. Okay, there are 3 types of discontinuities. Okay, the first one is going to be a removable. Okay, so give yourself a graph with a hole in it. Okay, that is called a removable discontinuity. In pre-cal, you probably called it a hole. Okay, and the reason that this is a discontinuity is because when you draw it, you have to pick up your pencil to skip this dot and then keep going on the other side. I'm going to just fill in my dot here, but you could put it anywhere, you could put it nowhere, it doesn't matter. Okay, if I can't smoothly draw through that circle, then it's a discontinuity, which means not continuous. Okay, your second type is going to be a jump. Okay, for a jump, I want you to make 2 lines or curves, doesn't matter, but they can't approach the same value. So I'm going to put a closed circle here, open circle here. Okay, but for a jump, you should have a gap between the left and the right side limits. Okay, the third type is an infinite discontinuity, which is going to be where you have an asymptote. So for your third type, you're going to have both sides going up is the example that I'm going to give. Okay, but you could have one side up and one side down. It doesn't matter if there's an asymptote there, it's considered an infinite discontinuity. Okay, so real quick, let's talk about what makes these discontinuities. For this one right here, okay, your left and right side limits, DNE. Now, remember that last week, when we were talking about limits and asymptotes, we were saying, like, for example, if they're both pointed up, it equals infinity. Okay, but remember that if your limit is going to infinity, it also doesn't exist. A limit existing means it's approaching a specific value. Okay, so your left and your right sides are both going either up or down, but either way, it's a DNE. Okay, go to your jump. If you have a jump, your left and your right side limits, they do exist, but what's the problem? Are they the same? No. So we're going to put here your left and right side limits exist, but not equal. Okay, a jump, you have a limit on both sides, but the problem is they don't come out to be the same value. Okay, go up to the removable or hole discontinuity. Okay, at the hole, are your left and right side limits approaching the same value? Yes, but your Y value is going to be somewhere else. So for example, here we filled in our Y value up here. So I'm going to put your left and right side limits. Equal each other. Exist and are equal to each other, but not equal to the Y value. Okay, and then remember that when we did our homework on this, your Y value has to be a closed circle. Okay, so I'm going to put underneath that a Y value is referring to a closed circle. Okay, So there are three types. You have a whole or a removable discontinuity, you have a jump, and you have an infinite. Turn the page when you're ready, please. Because we need those three things, we're gonna do a formal definition of how you can prove on the AP test that something is continuous. Okay, so the first thing that you're gonna need, we're gonna put this up here at the top. Okay, this is a graph is continuous if the first statement is that your limit as x approaches a from the left has to equal your limit as x approaches a from the right. That's the first thing that you're gonna check. Okay, the little minus is your left side limit, the little plus is your right side limit. You have to have those, they have to come out the same. That's step one to check if it's continuous. Okay, step two is you're gonna find what your y value is. Remember, we're looking for a closed dot in this step. So for step number two, we're gonna find whatever the y value is, and it has to be a number. Okay, so you have to have a y value. If you want to put here, you're looking for a closed circle. So I have to have a limit from the left and the right equal. I have to have a y value. The third and final step is that those two pieces have to be the same. So my y value and my limit have to equal each other. So we're going to put 1, 2, 3. And it's going to be that your limit as x approaches a has to equal f of a. So write it down first, and then we're going to practice writing it out using the formal definition. Okay? All right, so take a look at your first graph. When you're ready, we're checking for continuity at 6. Okay, we're checking for continuity at 6. You all still actually need that. Okay, so look at your graph at 6, and I want you to check the left and right sides of the graph at that spot. So 6 is here. From the left-hand side, remember, I'd cover up the other side. I'd pretend it's not even there. I'd trace towards and see where I leave off. What value am I leaving off at? 4. Now let's cover up this side. As I trace in closer and closer to 6, what's my y value approaching? 0. Then did my left and rights come out the same? No, so let's write it down. Okay, first thing you're gonna put is that the limit. This is step number 1. If you don't put this on the AP test, the little i's, it doesn't matter. Okay, I'm gonna do it just to follow the structure, but if you don't put that, it's no big deal. So we're gonna do the limit as x approaches 6 from the left. And then we're gonna find the limit as x approaches 6 from the right. Remember that to be continuous, these have to match. We said that our left side approached 4, but what did our right side approach? 0. Then at that point, you would say, oh, for step 1, these were supposed to match and they didn't. We can automatically make our conclusion. Therefore, 3 little dots, not continuous at x equals 6. Okay, why would I go on to part 2 if I already know that my first necessity didn't happen? Then I'm not even going to go on and check 2 and 3. Okay? Now let's look at our second graph when you're ready. Step number 1 is I need to check the limits from the left and the right. We're using a new graph and we're looking at x equals 2 this time. So put your little I. We're going to do the limit as x approaches 2 from the left. Then we're going to check the limit as x approaches 2 from the right. So I would draw my line in it too. I'm basically cutting the graph in half. And I'm going to look at each half by itself. So if I cover up this side and I'm tracing in towards 2, where does it look like the graph leaves off at? What y value? -1 is correct. Okay, then I'm gonna switch and check the right side, which means I'm covering up the left. And as I trace closer and closer to my yellow line at 2, where does this side leave off at? Also -1. So for condition number 1, did my left and right side limits equal the same thing? Then we have to go on to step 2. Okay, step 2 says that f of 2 has to be defined. Now remember, f of 2, what kind of circle am I looking for? Closed circle. So if I come out here to 2, I'm looking for a closed circle and I have it. Where is it? -2. So condition number 2, I do have a closed circle. Then I move on to condition number 3. Go back and read condition number 3. What has to be true about the limit and the y value? They have to come out to be what? Equal or the same, right? But did that happen for this question? No. So I would say my limit as x approaches 2 came out to be -1, but my y value is -2. Therefore, not continuous at x equals 2. Now, another question that I could ask you would be to classify what type of discontinuity each of those is. So if I were to ask you for this one, let me read you your choices. It could be infinite, jump, or removable. What type would this one be? Removable. What type would this one be? Jump. So if you want to label that, okay, there are some questions on your homework where you're just saying which one is which. Okay, removable is where you have a hole. Jump is where you have a gap between your left and right limits. Okay, does that make sense? All right, turn the page. So obviously it's going to be easiest to do limits if you just have the graph. Okay, but we can also do this with piecewise equations. So let's take a look at the next question. We want to know if our function is continuous at 3, but you're going to follow the exact same 3 steps. Step number 1, you're going to check the limit as x approaches 3 from the left, and then you're going to check it from the right. Okay, so go ahead and write out your structure, then we'll do the math in a second. If I want to approach 3 from the left-hand side, I am going to use x's that are less than 3. And if I want 3 from the right-hand side, I'm going to use x's that are greater than 3. Now, for my class, I always call this number the breakpoint. So if you hear me say that, BC kids, that's what I'm talking about. Okay, so my breakpoint here is 3. So to the left of 3, which side of the piecewise am I going to use? The top or the bottom? Okay, less than 3 is the top. So I would just plug into x squared minus 5. Now it's a 3 squared minus 5. 3 squared gives me what? 9 take away 5 gives me 4. So my left hand limit would be 4. For the right side limit, I'm going to use x's that are greater than 3. Would that be the top or the bottom of the piecewise? The bottom. I'm plugging into x plus 4, so now that's a 3 plus 4. 3 plus 4 gives me 7. So my left side came out to 4. My right side came out to 7. Do I go on to the second condition? No, because what is condition number 1? These had to come out the same. So you would ... Remember that means therefore. Okay, it is not going to be continuous at x equals 3. Okay, but I don't even go on to check parts 2 and 3 because if condition 1 isn't met, you're wasting your time going beyond that. Okay? All right, go down to number 4. Check the left and right limits on your own. I'll walk around and help. Okay, you're checking it at 0 this time. Okay, so think about what part you would plug in. Less than and left are the same, greater than and right parts. That's not 3 parts. And then greater than. That would be your F of C. Yeah. What is 0? Remember? Anything to the 0. So for this part, what are we plugging into? So it'd be 3 times 0 plus 2. Yeah, they should come out to match, yes? She feels a little like you should come out. Okay, I'll try that. Good. Okay, remember, e to the 0 is what? 1. Oh, is that what you're? Yes. Okay, so for the first one, you should have done x less than 0 and x greater than 0, which means that first I'm plugging into the top. 3 times 0 is 0, plus 2 is 2. Everybody get it? Yes. Okay, right side, I want greater than 0. I'm skipping to the bottom. E to the 0 plus 1. But then remember, anything to the 0 is always 1. It doesn't matter if it's a million to the 0, it still comes out to 1. So this is 1 plus 1, which gives me 2. Okay, condition number 1, did the left and right come out the same? Yes. Then we go on to condition 2. Condition 2 is I need to find where my closed dot would be. So I'm looking for f of 0. Okay, looking at your piecewise, if I want f of 0, is that an x less than 0, greater than 0, or equal to 0? Equal to 0 means I'm picking the middle piece, which is a 5. Okay, did I get a y value? Yes, I got 5. So condition number 2 is met. In condition number 3, what had to be true about those? They had to be the same, and are they? No. So in condition number 3, you still have to state it, but you would say basically that your limit came out to be 2, but your y value came out to be 5. Therefore, not continuous. Okay. Now, if it's a question on your test that's, let's say, like multiple choice or yes or no, do I expect you to do this every single time? Absolutely not. But if it's free response and it says justify your answer, that's where you would have to use these specific pieces. Okay? All right, I think we're going to do maybe just one more. We're going to do number 6 off the next page. Okay, number 6 off the next page. For number 6, how many breakpoints are there? Okay, count the numbers where it switches from one piece to the next. There are how many breakpoints? 2. Your first switch is at 0, that from less than 0 to greater than 0, I go from top to middle. And then I have a second switch at 3, where I'll go from the middle to the bottom. Yeah? So we're gonna check the left side, the x approach 0 side together. And then I'm gonna have you try the 3 side on your own. Okay, the question still is it continuous? Okay, or is it not? We're using our definition to show that. So step number 1, limit x approach 0 from the left, then x approach 0 from the right. Okay, now looking at your piecewise, there are only two pieces that touch 0. My less than 0 is at the top. And then this is also a less than 0 or a less than symbol. But I want you to think about x less than 0. If I want x greater than 0, is that what this really says? Okay, think about like the alligator eats the bigger side, right? So if it's eating the x is greater than 0. They just put the 0 first. So this and this are the same. Okay, so go ahead and plug into both pieces. See if they come out to match. For my x less than 0, we're doing e to the 0 plus 4. What does that come out to be? What number? It's going to be 5 total, because remember, anything to the 0 is a 1. 0 from the right side, we want x is greater than 0. That's going to be my middle category. Negative 2 times 0 is 0, but then I'm going to add 5. 0 plus 5 is 5. So condition number 1, we're good on that. I got a left side, I got a right side, and they were both 5. Step number 2 is I'm looking for f of 0. Okay, now, if I want f of 0, I want x to equal 0. Which part of my piecewise will I use if I want it to be at 0 specifically? The top, because it has the what? The little line underneath it is the equal to, yeah? So I would be plugging in only to the top, but I already know the answer. How did the top come out when I plugged in 0? 5, okay? So then in that case, did my left, my right side, and my y value all come out to be the same? So then your step number 3, you just have to state that my limit as x went to 0 was equal to my f of 0, which is equal to 5. Therefore, it is continuous at x equals. Make sense? Okay. So now you do the 3 side. This is the last one that we're going to follow that structure. Okay. For the greater than. So be your right side. Okay, your left side should come out to be what number? -1 is correct. Right side should come out to be what? 9. So do you go on to condition 2? No, it should be not continuous. Are we all good with that? Okay. Go ahead and turn the page. There's one other type of question that you're going to see on your Delta Math. So if you'll turn the page, this is your last question type. Okay, so what number 7 says is it's not saying, is it continuous? Here's what it's saying. You want to find the value of k that's going to make it be continuous. So if you want to make it be continuous, you know that you want the left and the right sides to come out to be the same. So what you're gonna do is you're gonna set them equal to each other. So for this question, if I wanna make it continuous, I'm gonna set the left equal to the right. So let's do that first. So we're gonna set the left and the right sides equal to each other. So I'm gonna have kx squared equal 2x plus k. Now, remember that they don't have to always come out equal. They only have to come out equal where you switch from one to the other. And remember, we call that the breakpoint. So at what value am I going to switch from the top equation to the bottom equation? 2, and we call that the breakpoint. So that's going to be at your breakpoint value. So in this case, I'm going to plug in x equals 2. Okay, but whatever your breakpoint is, that's what you're going to plug in. Now remember, x is becoming a 2 and we're solving for k. So for my kx squared, now it's a k times 2 squared. My other side was a 2x plus k, now it's a 2 times 2 plus k. What's my 2 squared right here? And then k times 4 is the same as 4k. On the other side, 2 times 2 is 4 plus k. And then what do we do to solve from here? How can I get this k over to the other side if it's a plus k right now? Minus it. So I'm going to minus my k across. 4k, take away a k leaves me with how many? So 3k equals 4. And then what would my last step be? Divide by 3. Very good. So your final answer would be that if my k is 4/3, these pieces are going to come out to be continuous. Okay, but you're making it continuous and then solving for what that number would have to be. Does that make sense? Okay, can you try number 8? So this time we're finding the value of a to make it be continuous. So you're going to do your left and your right sides equal to each other, and then plug in your breakpoint for this. What number is our breakpoint this time? -4. Very good. Good job. Okay, 10. Right that. Okay, for this one, if you're getting 9/8, that is correct. Go to the last one. If you're not there yet, though, take your time. Okay, but that's the answer that you should get. So let's just, for this, let's just make it 16. Then I think they times 16, so 7 equals 16. How do I get rid of the minus? Yeah. So divide by 16, that's right. But then cross these out. So your A equals 18 over 16, and since they're both even. So divide that 16 over 12. Yeah, it would just be A equals. Good job. The up to here though is perfect. So you add the 2K over, this should be a yeah. Okay, the next one does have kind of a little bit of a curveball. Yes? You're not really okay, everything to here is correct. You need to bring the 5 over and then back. Because you have the K squared. Yeah, do not. So say your side's equal, plug in your root. Oh. All right, so from here, this is, if it's negative 4 times negative 4, so this is a positive 16, and then instead of doing A times 16, I want you to make that just say 16, because that's the thing, right? A times 16. So you have 16A minus 11 equals 7 on the side. Okay, so we want to get this by itself. How do I get rid of the minus 11? Plus 11 on both sides. And 7 plus 11 is how many? 18 equal. These cross out, so now you just have your 16A and then divide that 16 across to the other side. So these are going to cross out. You have A equals 18 over 16. But since they're both even, simplify it together. Yes? Wow, you were. Good job. Let's find so let through five terms that are already on the same page. So if you have okay, so let's say 7. Say that negative 4 you try to add yeah, okay, well, let's undo that. We have 4. So combine your legs are on the same side. So he didn't want to now we'll get the A. No, you're doing great. Okay, this one has, so now let's minus this 2K over with those 6K. Okay, It's just saying for you, let's combine the like turn time so your 4 and your 2 cooking group together. Because that's solid. Okay. Last question. Let's just go over it so that we can get y'all into your delta math. So you should have k squared minus 2k plus 1 equals x squared plus kx plus 2. We're plugging in x equals 2. So k squared stays the same, but what's 2 times 2 for this term? Minus 4 plus 1. Then on this side, I have another x going to a 2. What's 2 squared? 4 plus. X is going to a 2. Now my k times 2 is a 2k plus 2. Everybody good to there? Okay. Did you plug it in for the k on accident?
No, how was it first? Yeah, because that doesn't simplify because we don't know the things, right?
Oh, was that a, wait, this
I
is,
think they used the formula wrong. It's like,
I wrote the formula wrong, thank you. It should be a minus k times, this was an x. K x, thank you. Okay, you're right. So then this should be a 2k, yeah? Yes, my bad. Thank you, I did write it wrong. Okay, from here. Hopefully you got that, because that's actually right. Okay, you should notice that one of your k's has a squared on it. Okay, so what that means is you shouldn't just get one answer. At the end, you should have 2 answers. So let's get everything onto the same side. I have a 2k and a 2k. One is plus and one is minus. Why can't I just cross these out? Why can't these cross out? Yeah, because if I minus this 2k across, negative 2k and negative 2k gives me negative 4k. So I have k squared minus 4k plus 1. Now, on the other side, I had a 4 and a 2. That adds to how many? 6. And then a lot of times at this step, y'all will try to like minus the 1 across and do weird stuff. Okay, remember, if it's a squared, you have to factor. It has to be equal to 0 on this side. Okay, that's a rule about factor. So I'm going to minus this 6 across so that my equation is set equal to 0. So now I have k squared minus 4k. What is 1 minus 6? Negative 5. And now we can factor. Okay, so set up. I know for us, we were doing the little x with the AC on top. Okay, if I multiply a 1 times a minus 5, what are we going to get for our AC? 1 times negative 5 would be negative 5. And then I'm going to list all the ways I can times the 5, which is just 1 times 5. But they need to combine back to my basement number of minus 4. So which side should I put the negative on so that my 4 comes out negative? The 1 or the 5? The 5. So then my factors will be an x plus 1, or in this case, a k plus 1, and a k minus 5. And then remember that your solutions are always the reverse. So if my factor is k plus 1, k is actually going to equal negative 1. And then if it's a k minus 5, it should be a positive 5. Okay? So if you have a k squared in your delta math, you should be entering 2 answers instead of just 1. Okay, go ahead and pull out your computers. Okay, and let's get logged in. For my new people, I'll give you your new code. Okay, your code's up on the board. You'll just add a new class. So this is. So we're gonna go left and right with this top of the thing. Your dot. Your skill. Does that make sense? Don't put X equals. So where's your first one? Right. So that would be negative one. First spot. And then you have another discontinuity.
That means that you're
Where else? Now, should I include this one? Well, none of them are continuous, right? So is this what we want over this whole because you're only looking for the ones that we were. Does that make sense? Yes, ma'am. You want to where your left and right one is every day your dot is so blank. That X value, like, you put a comma in between and it'll open up the second. Does that make sense? And then in the next question, it'll say like, find all the jumps or find all the infinites. Okay, yes. 2 is one of the answers. Why would it give you this one? The jump. Remember, it's one specifically removable. Just the numbers. Yes. It is, as long as the limits have to go to the stage. All right, so what are we looking for? You want only removables, right? So if you look at your first page, remember removables is where your left and your right sides have to go to the same spot, but then your dots just stay. So where does that happen on your graph for removables? Yes, what X is that? Give me the X. And then where else does it happen? So do -1, comma, and it'll open up a new box. And then 2. Now, should you also include 7? Exactly. So same for you. It's telling you which side to go. So you want removal. So if you look on your first page, remember removal. So like these 2, now why would you include this one? And then when you hit a comma, it's gonna open up a new box for you to put your 2 in. Can you ask that again? I don't think I know what you mean. Hold on, I'm gonna come. Are you good? Okay, Linus, you're reset.
You're done.
Okay. No, I have to know what. Oh, discontinuous, you want all. So they're not being specific, just any breaks in the graph. Could be a jump, could be infinite, could be. Yeah, now would you? Yeah, you only want. So remember that when we say a whole as a removable, they have to both be. Huh? No, this is one type and then we are both called. Actually, I forgot to write that down. Y'all, real quick, this could be confusing on your notes. Let me just show you for 1 sec. On your first page, I ignored that I had set this up so carefully and I forgot it. For your first one, it's called removable. You remember that? We talked about that? Okay, then the other two types, jump and infinite, those count as non-removable discontinuities. And then within non-removables, you have jumps and infinite. Now, the way your Delta math breaks it down is the original titles I already gave you. But all of them are discontinuous. Removable is its own type, and then jump and infinite are considered non-removable. Because essentially there's a bigger problem than just one dot missing. Okay? What? So look at your graph. So it's saying on the interval from -9 to 9, that's what you're already looking at. Say everywhere the function is discontinuous. Now remember, discontinuous is any. So now they're not saying, I want only the whole and I want only the jump. So if any breaks in the graph, you have to. If the dot's not where the graph is, then you have that break. That would count as a. Remember, these are all three types of dysfunction. Now, even if the dot's not there, this still counts as break. But the dot would be there unless. Okay, well, that's 0, then I just make it 5, so the limit has to be this, right? If they came out different, it would be a negative 1. And you say your y value is -0. Therefore, it's not continuous because the limit is, I thought this one we said the limit didn't. Yes? So then where's your next issue? One, comma, where's your next one? 2, and then? Huh? 80. And then which of those was your jump? Correct. So if it had said, like, I want only the removables, then you would not. Thank you. Okay, so then for this one, if you want to look, it's continuous. You're going to plug into the top, the bottom, and see if they differ. Remember, I would like to be continuous. I'm going to do this one. That makes sense. Yes, on it. That'd be any types. Yes. Either one, yes. Correct. Yeah. Well, it has to be approaching the same number, but you can't be missing the dot either. So if it says discontinuous, then any of them. A whole, a jump, or all of those would count. Because they're not giving you a specific type that they want. Let me reset and then I'll come right back. Yes, Daniel. 0. I think your 5 should be a -5. We're about to do that one. Change your 5 to a -5. And then where it says the limit exists, if the left and rights came out different, should you have that? It should say the limit does not exist. Okay. Yes. 5 and 6, let me see your question. What's it asking about when you jump? Okay. So you're good from there? So which of those should you take out as a answer? That's a jump. That's a jump, that's a jump. What about that one? That's a removal. So you want to take 0 out of it. So go down here and push the minus right there. And then replace the 0 with the 6. They don't have to be in order. You just have to get all of them.
So you did 1 is correct, 2 is a jump. Why is 2 a jump?
Oh,
Yeah. And then 0 should have been used. So what's that X? What you used? 4 is correct.
okay, when you get to the definition one, we're gonna do that one together. Oh, that's the one we're about to do. Okay, I'm gonna do this one and then I'm gonna leave it up there so that you can look at it longer if you need to. Okay, so you're going into, if you'll just skip ahead to the question on the definition if you're not quite there yet. Okay, I'm on this one. So it's 1, 2, 3, 4, 5 from the top. Okay, at -1, that's the point I'm looking at. Notice that the structure of your proof is already here. -1 is this value right here. What is the left side value? Right there. What number? It is 0. Very good. That's correct. Okay, what about the right side limit as I approach -1 from the right side? -5. Now, if those numbers come out different, what do I conclude about the limit as x approaches -1? It does not exist. Okay, and when I click this to does not exist, the what it's equal to goes away, because if it doesn't exist, it's not equal to anything. Okay, then it says, furthermore, it can be seen that f of -1, they're looking for the y value. Where is the y value at -1? Remember, I'm looking for a closed dot for that. 0 is correct. Now, for your notes, would I have even made you find this? No, because if part 1 is broken, I wouldn't have even made you go and find this, but Delta Math does. Okay, so then it's stated, is it continuous or not? No. Because if my limit doesn't exist, it doesn't matter what my y value is. Okay, because it can't be equal to it if it doesn't exist. Okay, then it says because. Is it true that my limit was equal to -1's y value? My limit as x approaches -1 doesn't exist, or the limit exists but wasn't equal to the y value. Which of those is correct? Top, middle, or bottom? What did we say about our limit? It did not exist. Okay, so make sure as you're going through those that you're just going step by step. Okay? Yes. Remember that, no, a select, a point isn't watching. A line isn't. So pretend that that line is all of the type. No, it's the accurate. We're combination for it, it's correct. Yes. Your y value would be equal to self. Well, the limit is not. What was the limit? So your limit should say this, and it's -2. The y value is -3. So then are we saying continuous or not? Okay, stop, continuous, and then from the drop down, you're gonna say, we did have a limit, but it wasn't equal to f. Does that make sense?
Yeah.
Yes. So then this says that those have to match with the exist. So you want that to be.
Okay, now your reason says should be. There we go. Good job. Is it? So if you're looking for all of the removable discontinuities, you're looking for all of the places. Oh, so. Now, let's go back on your 97. That is the description. So that limits from each other. So then it was. Because that one was -7 should be. Looking for removable. Oh, the right time to sustain, just that one down. That'd be -1, so you're missing the exit. And then when you hit a comma on your keyboard, it'll open up a new box where you'll put the. That's what the number is. Oh, gotcha. Okay. Yes. Okay, so your left and right limits, you said were -2. That's right. It's not, okay, it's this right here. You told me. So let's click right here. Your limit exists, and what's the problem? F of -6, right? So out of your choices, you want the limit to exist, but not to be. So see how on mine, the left and the rights didn't come out the same. So that's how come I picked this answer. Yours, your limits did come out the same. The problem was that this number was different. So you have to pick a different piece. It should be the third one. Yes. Okay. Oh, Dyson, you're in a problem set. It'll just give you a new one. It won't take off points from your grade though, correct? All right, Daniel, you reset. Yes, Mom? Sure. All right, Lamek, you're reset. Yeah. Discontinuous, you want any breaks in the graph, so that one. No, you also have one more. They don't have to point the same way, they just have to have a house. They also should have to. Sure. Yes. Is there any dot available for you to choose? Then you'll pick undefined. Do you see the little button where undefined is? Y'all, if there's not a closed dot, remember that means it's undefined. Okay, Natalie, you're reset, hun. Just refresh your page. On today's one? Yeah, sure. In the F of, are you on the, it's like F of -6? Yeah. So you would just pick negative, undefined out of the choices, but you only pick that if there's no Y value available. So if there's no closed dot for you to choose, that's when you would pick that. Does that make sense?
Hang on, I can't see that. Too blind, sorry, Daniel. Okay, Maggie. Maggie, I think you're in a problem set. Do you, it's on today's, you said? It'll just give you a new one.
So if it's out of 3, it shouldn't hurt your grade, even if you get 10 wrong in a row, you just have to eventually get 3 right. Okay, so you did -4 from the left is gonna be 5. Right is 5, so it exists and it's 5. F -4 is 5, so it is continuous. So for your because, you're gonna say the limit exists and is equal. Good job.
It's just that they all have the same guy.
Yes. Huh? We don't even- I see that. Okay. You have a question? What's gonna happen is that your homework average is gonna transfer into all the homeworks that happen. So let's say you've done 100% of your homework, that's gonna put, so let's say that you've gotten all of my homework. You want to go back and you want to find homework, all of them. Oh, I did my homework. So I would say, if you want to finish that, you can, but if it's not over, you won't stop. It's gonna be your homework average, so unless you can already type to a bunch of waiting, then it won't. Yes. For the limit, we did -2, because that's your left, your right hand side, but then for F, the negative 6. So then are you gonna say like no, so do not continuous because.
19, but it's.
Yes. You're gonna plug -2 into the top of the bottom.
Okay, great.
All the values.
Alright, great.
Yeah, because remember, in order for the people, the left and right one doesn't have to mix with it. Okay, one more thing, I hate to do this to y'all, but you have 25 minutes. This is a quiz, but it's not a quiz grade. It's gonna be for my kids, just like we did last time. For the first 10 minutes, I want you to try it by yourself. Okay, this is for you to know how you're gonna do on Friday. You may not be able to do every question, okay, but I want you to do as many as you know how to do without any help. And then all come around and answer questions, then after 10 minutes, if you wanna work together, you can. Okay, go. If you did not finish your homework, don't sweat it, you have all next class that we're gonna be reviewing as well. Okay, skip 1, 2, 3, 4, and start on number 5. Okay. Go, start on number 5. And then remember, quizzes are open notes. So I don't know, BC kids, if y'all have good notes, but AV kids, get out your notes. Start on number 5, not 1 through 4. All right, 10 minutes. We're not helping each other. We're trying on our own to see what we remember. Rebecca, you're in a problem set. It'll just give you a new. Because you see at the top, it's 3. Skip 1, 2, 3, 4, 7, 5.
Okay, when you look at your limits, what do you do if X is approaching a number? Okay, y'all, if X is approaching a number, what do? Trace the number? What does that mean? Okay. Look at your quiz. Let me just, since there's a lot more of y'all now, so that I can just get you all on the same page. You're not doing 1, 2, 3, 4. Number 5, 6, and 7. This one's going to a number. What were the strategies that we talked about last class? The first thing you should try is to take the number and do what? Substitute it or plug it in. Now, if that doesn't work and you get 0 over 0, do you remember you can try factor cancel? Okay, and then if that doesn't work, what if you can't fix the limit? Then you put what? Do you remember? Any. Now, what if the limit's to infinity? Do you remember you do Boba, Bot, and Betsy? Yeah. So if X is going to infinity, it's your Boba, Bot, and Betsy rules. If X is going to a number, you're going to try to plug it in. And if you can't plug it in, you're going to try to do more. Okay? All right, raise your hand if you need help. You're doing these on your own for now. I don't think so. I thought it came out to like 5. No, 3. So did you plug in X approaching 1? So on top, what's 1 cubed? Minus 4? -3, right? So the top is a -3.